Here is our very first question. We are told that a copper rod of diameter 20 millimeter and length 2.0 meter has a tensile force of 5 kilonewton to it. So let's write out our given data. We are given the diameter. Diameter is given as 20 millimeters. We convert this to meter, it becomes 0.02 meters. Alright, we are given the length of the material. The length is given as 2.0 meters. Alright, so we are given the tensile force. The force is given as 5 kilonewton. 5 kilonewton. We convert this to Newton. It becomes 5 times 1,000. That gives us 5,000 Newton. Now question, we're asked to find the stress in the rod. So the stress is not given to us. We have to find the stress. And the next question is that to find the how much the rod extends. So that is the extension. So we have to find the extension of the rod when the force was applied. And also we are given the modulus as 96. So our E, capital E, is given as 96 gigapascal. Remember that gigapascal means 10 to the 9. So I can convert this to Pascal. It becomes 96 times 10 to the 9 Pascal. Alright, so now we can find our stress. So the first question is A, find the stress. So A, we have to find the stress. The stress is equal to the force over area. Force over area. Now my force is known, but the area is not given. I can find the area. I know that area is equal to pi d squared over 4. Alright? Now the reason why I'm using this equation is because the rod is in the form of what? A cylinder. So we use this formula for the area. So therefore my area is equal to pi times my diameter is 0.02 squared, 0.02 squared divided by 4. So therefore my area is equal to, so when you put this in your calculator, we should get 3.1416, 3.1416 times 10 to the minus 4 meters, minus 4 meters squared. So that is our area. So therefore I can find my stress. So stress therefore becomes, the force is 5,000 divided by the area, which is 3.1416 times 10 to the minus 4. So therefore 5,000 divided by 3.1416 times 10 to the minus 4 will give us 159,154 57.09 Pascal. 0.09 Pascal. All right. Now I can convert these to to megapascal, it becomes what? So I take my decimal point, I'll move it 6 places backwards, so it becomes 1, 2, 3, 4, 5, 6. So that's a 6, that's a mega. So we now have what? 15.9 megapascal. So that is the stress in the rod. That is our answer for the stress in the rod. Now, the next question is that we are asked to find the extension, by how much the rod extends. So to find the extension of the rod, the first thing I do is this. I can use this equation right here to find the extension. All I have to do is to transpose, or I can find the strain first, which I will do now, because I know that modulus is equal to stress over strain. So I can find the strain first, then from there I can find my extension. So when I transpose this equation, I get strain is equal to the stress over the modulus. So I can log in the values. My stress is 15.9 megapascal, so I can say 15.9 megapascal means times 10 to the 6 over the modulus, which is 96 times 10 to the 9. Remember, this is 15, that's 15. All right, so therefore my extension in this case, when I put this in my calculator, I should get 1.6563, 1.6563 times 10 to the minus 4. Remember that strain has no unit, so there's no unit for strain because strain is dimensionless. So now I can find my stress, or sorry, I can find my extension. Now I know that strain is equal to extension over the original length. So now I can find my extension with this equation. So I can transpose. So we have extension is equal to the strain times the original length. All right, so therefore my strain is 1.6563 times 10 to the minus 4 times the original length. The original length is given as 2.0 meters. So the original length is 2.0 meters. All right, so therefore the extension of the rod, when we multiply 1.6563 times 10 to the minus 4 times 2, will give us 3.3125. 3.312, okay, 12 times 10 to the minus 4 meters times 10 to the minus 4 meters. So that is the extension of the rod. So this is our final answer.